AP Calculus, section 4.1, page 2. All right, I would like to identify all of the extrema, max, mins, relative and absolutes for this particular function over here. Extrema, relative and absolute, max, mins. All right, in order to do that, we need to sketch a graph. So 1, 2, 3, all right, so when we start to graph this, y equals x plus 1. That's a line. Y-intercept is 1. Slope is 1. I am not going to keep counting slope to the right because that graph is only valid when x is less than 1. So if we count slope backwards, and then recognizing this part over here, this graph is only valid from x is -5 up to 4. So I know this is linear. Let me find my last point out here at -5, -4. Oh, my scale is off a bit here. That's all right. As long as we identify that ending point down here as -5, -4, we're good to go. This is open up here because this line is only valid for when x is less than 1. Now when we try to graph this quadratic, we think it might factor, but if we try x minus 7 and an x plus 1 to get that -6, we won't be able to get a positive 7 here. So we do have an issue. This does not factor. But we don't have very many points here because this graph can only go up to 4. So if we can just sub in and plot some points, that'll work. Start at x is 1. We have 1 minus 6 is -5 plus a 7 is 2. Oh, so that parabola is going to pick up right where that line leaves off. Plug in a 2, that's 4. Minus 12 is -8. Plus 7 is -1. Plug in a 3, that's 9. Minus 18, it's -9 plus a 7, -2. So 3, -2. And then the last point that we need to check is 4. 16 minus 24 is -8 plus a 7 is -1. And we stop because this graph is only valid up till 4. And we have a nice parabola here. I'm just going in and labeling some other points. This one up here is 1, 2. This point was 3, -2, and this one was 4, -1. Okay, looking at all of these points. Over here we have a relative minimum and an absolute minimum. This point up here is a relative max and an absolute max. And this one right down here, that is a relative min. And one more over here at 4, -1. In the nearby area, that's a maximum, so we have a relative max. All right, now notice that where we have our relative extrema, we have something going on in terms of derivatives and slopes of tangents. We have a horizontal tangent sitting right here, and we have a derivative that's not defined here because the slope of the tangent from the left does not equal the slope of the tangent from the right. So when we are analytically trying to find these extreme values, we are interested in something called critical numbers. A critical number is a number, it's an x value that helps us find extreme values. Critical numbers help us find extreme values. The definition of a critical number is the following. A number C is a critical number of f of x if f prime at C is equal to 0, or if f prime at C does not exist, or if f prime at C is undefined. Okay, I would like you to graphically estimate the critical numbers off of that function. And I should have typed it in first. I didn't. That's okay. X to the 4th plus 4x cubed. Oops. Let's start this over again. X to the 4th plus 4x cubed minus 2x squared minus 12x. If we graph this on a standard viewing window, we can actually see a pretty nice graph. And we see that nice W shape. Okay, estimate the critical numbers. So critical numbers are places where we're going to have extreme values, the maxes and the mins. So I want you to look on here, and we're going to look for the x coordinates of the relative extrema. So the relative max, the relative min. They're nice. There's one right here at -1, there's a maximum. At -3, we have a minimum. And at x equals 1, we have a minimum. So our critical numbers are plus or minus 1 and a -3. All right, now I want you to confirm your answer analytically. So critical numbers are where that derivative is equal to 0, or the derivative doesn't exist, or the derivative is undefined. So we need to find the derivative. Let's go find f prime of x. F prime is 4x cubed plus 12x squared minus a 4x minus 12. Let's factor this. 4 terms, we can pull a 4x squared out of the first two, which leaves us with an x plus 3. A minus 4 from the last two also leaves us with an x plus 3. This will then factor into 4x squared minus 4 times x plus 3. This 4x squared minus 4, we can pull a 4, which is then x squared minus 1, and that factors as the difference between two squares. So we have 4 times an x plus 1 times x minus 1 times an x plus 3. Now again, to identify critical numbers, we are interested in where f prime of x is equal to 0, where f prime is undefined, and where f prime of x does not exist. All right, f prime is polynomial. There is no place that that does not exist, and there is no place that f prime is undefined. The derivative is a polynomial. It's defined everywhere. It doesn't have any problems here. So then where does f prime equal 0? F prime equals 0 at -1, 1, and -3. Which matches exactly what we came up with right up here. Okay? Then this last bit, I want you to graph the numerical derivative of that function. All right, so now let's go here. I'm going to leave this one here, but I'm going to turn it off. And then let's come over here, and I want to graph the derivative of y1. So that's alpha f2 and derive 3 d dx of y1. That's alpha f4 at, all right, I want the derivative everywhere. So at x equals x, graph. And it's okay that it's off the screen. That's all right. What I'm really interested in is this is the graph of the derivative. Notice that the graph of the derivative has zeros at -3, at -1, and at 1. That's one of the big things I wanted you to notice. Notice that the graph of f prime of x has zeros at ±1 and -3. So if we put this all together, can you see that the horizontal tangents on f of x are the zeros on f prime? Horizontal tangents where the derivative is equal to 0, slope of a tangent is equal to 0 right here. And maybe if we put these right back on top of each other, I paused it for a minute. Oh, I think I stopped it. That's okay. I meant to pause it. All right, so right down here, horizontal tangent at x equals -3. Horizontal tangent up here at x is -1. Horizontal tangent here at x is 1. Let me continue graphing. I think it gets confusing when both of them are together. -1 is a 0 on the derivative. Oh, that was -3. -1 here and 1 over there. It's too confusing. I don't like that. I have to keep them separate. Maybe you can see them. Anyhow, thanks very much for tuning in. Check out page 3.